In this video, we will do states of the encoder, code tree, and then we will also see how to draw complete code tree. Further convolutional codes. We will consider the same previous example in order to understand code tree. Let us see first how to get the states of the encoder. In our figure, we have shown that the previous two message bits M1 and M2 represents the state. The input message bit M affects the state of the encoder as well as the outputs V1 and V2 during that state. Whenever new message bit is shifted to M, the content of M1 and M2 define new state and outputs V1 and V2 are also changed according to the new state M1 and M2 and also the message bit M. Let's define the states of this particular encoder. So we have two bits M1 and M2. So we can have four possible states. That is, the first state is the initial state, that is 0, 0. Then we have 0, 1, 1, 0 and 1, 1. Let us give arbitrary names for these states A, B, C and D. Now let us see what is a code tree. In a code tree, each branch of the tree represents an input symbol with the corresponding pair of output binary symbols indicating on the branch. Now let us take an example. Suppose we have a message sequence 110. For this message sequence, I need to draw a code tree. Initially, assume the state of the encoder as 0, 0. So we have M2, M1 is equal to 0, 0. So that means the encoder is in state A. Let the first message input be M is equal to 1. So we will have two parts here, before shift and after shift. So before shift, we know that M2, M1 is equal to 0, 0 and we are considering the first bit that is equal to 1. So by using these bits M, M1 and M2, we are calculating the output bits for V1 and V2. So we know that V1 is equal to M modulo 2 addition M1 modulo 2 addition M2. So we have 1 modulo 2 addition with 0 modulo 2 addition with 0. So that is giving us an answer equal to 1. And V2 is equal to M modulo 2 addition with M2. So we have 1 modulo 2 addition with 0. So that is giving us an answer equal to 1. So we have V1, V2 is equal to 1, 1. So the values of V1, V2 is equal to 1, 1 are transmitted to the output and the register contents are shifted to right by 1 bit position. So after shift, M will be transmitted to M1, M1 will be transmitted to M2 and the M2 bit will be discarded. So we have M1 is equal to 1, M2 is equal to 0 and the second bit of the message sequence will be entered at M. So we have 1, 1, 0. So after shift, we have the next state of the encoder, that is M2, M1 is equal to 0, 1, which corresponds to B state. This shows that if an encoder is in state A and if the input is M is equal to 1, then the next state is B and the outputs are V1, V2 is equal to 1, 1. The code tree diagram always starts at node, or here it is state A. Now it may be observed that if M is equal to 1, we go downward from node A. Otherwise, if M is equal to 0, we go upward from node A. It can be verified that If m is equal to 0, then next node is A only. Since m is equal to 1, here we go downward towards node B and output is 1, 1, which is indicated on the branch. The figure is shown in the slide. Now we will see how to draw a complete code tree for the message sequence 110. The initial state of the encoder is state A, that is M2 M1 is equal to 0, 0. The first message input bit is M is equal to 1. So with these inputs, we are calculating the values of V1 and V2. The values of V1, V2 is equal to 1, 1 are transmitted to the output and the register contents are shifted to right by 1 bit position. Hence, the new state of the encoder is M2 M1, that is equal to 0, 1, which corresponds to state B. So when you start drawing a code tree, the first node you mark the initial state, that is equal to A. Since the message input bit M is equal to 1, we go downward direction and mark node B. On the branch, we indicate the V1, V2, that is output value, which is equal to 1, 1. Then the next input bit is taken, that is equal to 1. So we have M is equal to 1, M1, M2 are the shifted values, that is equal to 1, 0. Again, the V1, V2 values have been calculated, that is equal to 0, 1, and the register contents are shifted towards the right by 1 bit position. So the new state of the encoder is M2, M1 is equal to 1, 1, which corresponds to state D. Thus, the encoder goes from state B to state D if the input is equal to 1 and the transmitted output, that is V1, V2 is equal to 0, 1, is marked on the branch. Then the third input bit of the message sequence is taken, that is equal to 0. So we have M is equal to 0 with M1, M2 is equal to 1, 1. Again, by using these bits, we are calculating the values of V1 and V2. So we have V1, V2 is equal to 0, 1 and the input bits have been shifted towards right by 1 bit position. So we have a new state, that is equal to 1, 0, which corresponds to state C. So when you are drawing a code tree from node D, since M is equal to 0, we have a upward direction towards node C, and on the branch we are marking a value of the output bits, that is equal to 0, 1. In the next video, we will see by using code tree how we can get the codes of any message sequence given to us, and also see one problem based on convolutional codes. Thank you.